So I see the signs that the schedule of the day is tiring us all to a degree. So welcome to the next session about healthcare analytics. We have 3 talks, and we also will serve as a panel. So each of us will give about 10 to 12 minutes, I hope, and then we'll have, hopefully, ample time for questions. So I'll start by talking about something I have focused my attention in the last decade or so on personalized medicine. And to motivate, I would like to say, as you perhaps have experienced, medicine today is by and large not personalized. So patients with similar symptoms and diagnosed with the same disease are typically given the same treatment, independent of their history, biological variations, and hereditary factors. That's an observation. The second observation is medical education has not really changed since the 1920s. Johns Hopkins, about 100 years ago, introduced this new system of educating medical doctors, and by and large, the system has not changed too much. Correspondingly, one can ask questions like, can we improve outcomes for patients by personalizing the treatment? How should you educate the new generation of doctors? And closer to us, how should we educate the new generation of analytics graduates? Another motivation is our field. At least in my view, operational research has focused predominantly in the last 30, 40 years, although not in the beginning, from models to decisions. Data has not been in the center of attention. I would say is a supporting actor, not the protagonist, definitely not the director. Machine learning, on the other hand, has focused primarily from data to predictions. Decisions, again, is a supporting actor, not the protagonist. In my view, as many of you know, the future is in the union of the two, namely the process from going from data to models to decisions that add value. And the question is, can we utilize this paradigm in medicine? So let me give you a bit of a vision of how I envision, hopefully within my lifetime, of 21st century medicine. Imagine a patient who visits a doctor and gives the doctor access to his own medical history. Perhaps through the discussion, the doctor can input some specific details of the discussion with the patient. An algorithm runs in the background to propose alternative diagnoses and treatments, personalized to the patient, and also with an explanation of why humans, especially regarding your health, I believe, need explanation. A report is produced about the success of treating the patient and possible side effects, and I consider this a vision of very personalized, analytics-driven medicine. Here's a vision for the next 35 years of the ORC in that narrow area. So imagine the ORC in 20 years offers analytics degrees in analytics in medicine, in collaboration perhaps with a new college of computing. Not only, of course, medicine, law, music, many other aspects of human knowledge and experience, I would say, will be affected by that. That's the reason I'm excited about this college of computing. In a different field, medicine, suppose medical schools train doctors in analytics, data-driven, algorithmically driven, and so forth. And then electronic medical records, genomic data, images, and reports, radiology reports, various types of reports that doctors use, in my view, provide an unprecedented opportunity for our field to affect medicine. And in my view, in the 35 years I've been around, I consider it perhaps the most important opportunity in my career. And I would say is still on the balance. I do not believe any field has decisively claimed this area. So, and I think we are, if we play our cards correctly, we are well positioned to do that, perhaps utilizing other areas, natural language processing, computer vision, many others. So this is sort of the overarching objective. In terms of aspiration of this work, what I set out to do about a decade ago is to develop personalized methods in medicine to improve outcomes for patients, to affect medical education, to affect also analytics education. I also have a personal motivation. In 2009, as some of you know, about a decade ago, I lost in the same year my mother, my father, and my aunt to various diseases at roughly an age of 75. And I always felt, even though I couldn't help at the time, is that a personalized approach to medicine might actually have helped them. So even though one cannot help their own, maybe others could be helped by using that. So what I would like to tell you very briefly is an example of something we developed here at MIT, not in medicine. It's a PhD thesis I supervised by Jack Dunn, a paper that just appeared in Machine Learning last year, where we utilize OR methods to develop algorithms for regression and classification that are sort of state-of-the-art, but also equally far more interpretable than others. Just to illustrate, this is the notion of decision trees. If you don't know it, you will not understand it from my talk, but think about something that adds questions. Is the temperature of a person more than 100 or less than 100? In one answer, is the blood pressure higher or lower? But using optimization to find it. So the red curve is the classical method called classification regression trees. The blue is the performance. The horizontal axis is how deep the tree is, and the vertical axis is out of sample accuracy, on average in a class of about 60 real-world problems ranging from small to very large. And the green is the corresponding thing with, but instead of using partitions of the space with horizontal and vertical partitions with hyperplanes. So you ask, is 2 times the temperature plus 3 times the blood pressure more than 113 or not? Which is not as interpretable, but as you will see, it has, but more interpretable than a complete blood box. So the curve knows, the second curve, I don't know if I can see it, this curve is what is called random forest. So about the same as the very interpretable trees. And the trees with hyperplanes are very close to performance, slightly better, in fact, than the method I mentioned in the previous presentation about XGBoost. In other words, we have a method, the details are not important, that gives rise to interpretable algorithms. As you will see, I give you some graphs, but are particularly important in medicine. That is, in medicine, in my view, if you have an algorithm that, let's say, predicts life and death, it predicts mortality, and you say the algorithm predicts death, and the accuracy of this is 99%. All is great, but if the patient asks why, and the answer is the algorithm said so, I suspect that's not an answer that many people would like to hear. Whereas if at least you understand it, I think there's a better chance of being adopted. So with this idea, I would like to give you some examples of how we utilize these methods for personalizing prediction and treatment in a variety of medical areas. So the group here at MIT, which is sizable, aim is to revisit the major human diseases using data and machine learning to develop that includes sort of hundreds of thousands, if not millions of patients, and to develop guidelines and methods that are interpretable and give rise to more personalized treatments. Here's an example. So this is recently developed with a group at MIT. Jack Dunn was involved, as well as colleagues for Mass General Hospital, the trauma area, in which the problem is as follows. A patient comes in the emergency department. They are typically in a coma or not communicative. The only thing we have is data, from medical data, perhaps X-rays if there is time, and so forth. The question is, before you act, how likely, given what you know, given the operation you are thinking of doing, how likely it is a person will die, how likely it is that the person will have serious complications. And you cannot perhaps see all the details, but using about 300,000 patients from the national database, including many hospitals around the country, including Mass General, in relatively few questions, 4 or so, that doctors understand, even now I understand, given that I'm more knowledgeable in this area, you get a better understanding of the risks involved. So the system is currently in use at Mass General Hospital. About 50 doctors use it almost daily. And the key aspect of it is that it gives you a sense of predicting things from the totality of experiences of what we have. A personal physician, of course, has experience, but very limited compared to hundreds of thousands of people. And the way it is being delivered is through, the particular application is called Potter, P-O-T-T-E-R. You can download it if you like, not that you are about to enter the emergency. I was actually recently, this weekend actually, I was visiting the emergency department in a major hospital for a relative, and I could see, it wasn't Mass General, it was another hospital here in Boston. They did not have it. But I did speak with a physician about using it, and he was quite complimentary after trying it for the day. So a bit of marketing while in the emergency department. Although, so the idea was using an app, it asks questions. And I have found if you don't have interpretable methods, you are not even in the dialogue of being used, even though if you are fantastically accurate. If you use a neural network for this, for example, even let's say they are about the same accuracy, even higher, chances are it would not be utilized. And this is from experience, not hearsay. So another example is mortality prediction for cancer patients. This was also motivated by an experience I had with my father. My father was sick with stage 4 gastric cancer, and until the very end, the doctors here at Mass General wanted to give him chemotherapy, even though, at least to a non-expert like me, it was obvious that he was dying. And they were doing it with good intentions, is to help him, is to basically try to elongate life. But on the other hand, if you have an algorithm that is calibrated with, let's say, millions of patients that tells you this patient in the next few weeks is about to die, it gives you much more evidence, much more certainty, perhaps to avoid these treatments, and vice versa. If you saw, very significant improvement in the chances of a person surviving and without being too toxic, this is also, I would say, a sign. Again, interpretability is relevant. I think you get an idea. You can apply this on many other areas, critical brain injury, transplantation, oncology. I would leave oncology out because in the end, I would say Vijay will have some very exciting things to say. But I also believe in oncology, especially with genomic information, the opportunity is fantastic. And I really think it is our field that can, not only our field, but our kind that can make a difference here. So just to mention the idea here is that we utilize data. This is work with one of my former students, Daisy Zuo. We utilize data from Dana-Farber and the Broad Institute, genomic information for mutations on cancers. And it is my belief that cancer is not one disease, multiple disease. And the idea is that a particular drug can hit particular mutations as opposed to what is done primarily here, Strand notwithstanding. But if you go to a hospital today, by and large, they give chemotherapy one size fits all, more or less. And what we have discovered, although there have been signs in the very recent years that particular drugs can hit particular mutations, particular immunotherapy is a good example, is that using a big data story and using optimization to find which drugs can attack which mutations, we found in this work specific drugs that can hit specific mutations, and we are currently in trying this out for very sick patients. Patients, in other words, who have exhausted, it's not a formal clinical trial, who have exhausted other means for trying things. just to tell you a little bit in conclusion, I find this is an exciting area. I mean, people who are around me, of course, know that because they see the excitement. And the group here has been developing personalized treatments for a variety of major human diseases, various types of cancer, cardiovascular disease, stroke, blood pressure, and many others. And I feel the area is particularly exciting for both research as well as education. So I'm scheduled to teach a class with the audience is medical doctors in the last year at Harvard about these ideas. So we'll see how successful we are. For people that are not trained like us, that would be, I would say, a challenging endeavor. I will be more a wiser person next time after I had some experiences. Thank you. Our second speaker is Natalie Youssef, a recent graduate from the OR Center, and she will be talking to us about the company she has been leading called Maya Analytics Health, Maya or Reclaim.
Thank you, Dimitris. I want to tell you about a company that we started about 2.5 years ago, also in the healthcare space, but we're, instead of looking at the personalized medicine, what our area is personalized healthcare. What we have created at Maya Health is Reclaim, which is an individual focus, if you will, a healthcare user-focused application that helps healthcare users, individuals, just patients just like us, being able to manage their healthcare cost around their healthcare needs. So really, we wanted to make it simple. Just as it's simple to look at our bank statement, unfortunately, this is not how it is like currently in the healthcare space at the moment. I have an anecdote that I always say. As I was moving out of MIT, I had an episode. I fainted. And that prompted a series of healthcare services that I had to undergo. Amongst them was an MRI of the brain. I did one under the graduate student health plan. I paid $50, and I had no bill come to my house. I had nothing to worry about. And then as I moved out of MIT and I got another health insurance plan that I did not understand at the time, and I went for my 6-month checkup. The same place, the same doctor, the same provider. I paid $1,253 for the same brain MRI. And it was enlightening. Just to say the least, it really matters what assets really we have in terms of insurance. But not only this, is understanding that there's variability of cost from provider to the next. And it's also understanding, did I really need that brain MRI to be told at the end of the day, you didn't have a good night of sleep. And this is why you fainted.
The green light.
Okay. So we have basically developed Reclaim, which is an application that helps individuals save a median of $1,500 in a number of cases, especially when we are talking about more complex care. We could see thousands of dollars and tens of thousands of dollars of potential gains that we could give to the member. So just let me give you an idea just to introduce what we're doing. And then you're gonna see some of the analytics where it is sprinkled around in various aspects of the offering. So the first aspect is we bring people their information about their claims in an understandable way. So this is not the raw claims, the way the insurance portal would give you access to them. We have used analytics along with clinical expertise to bring all the raw claims data into events and episodes of care, the way we would understand them. I went for a fainting episode. My doctor's visit my MRI, any follow-up is going to go all under that one condition, if you will, or episode. And that gives us a lot more understandability in terms of the machine learning that comes after this. So just before I go on to the predictive side, after we've incurred some bills, there are ways that we can go and retroactively save an individual money. We are able to, we have algorithms that can fetch reimbursement opportunities for claims that were already incurred. Appealing charges that normally you shouldn't have been billed for in an episode that is similar to yours. So again, we see that from the data, and not such a normal activity, if you will, as well as appealing charges for out-of-network services that you got at an in-network facility. The concept that was very interesting to me as I am working on this is that I came to it from an algorithmic perspective. So I was thinking, I've got a lot of claims data, I'm doing all the analytics. What I got to appreciate through this is the presentation to a user. How do you package the insight? How do you package the conversation for a user? That was very interesting to learn and to learn from team members on our team. But the power of the data-driven approaches and the way that we see claims and we see those opportunities is in one, the predictive power of it. What can I say about your needs for the future? And that helps in a number of ways. It helps in financial planning. If I just got diagnosed with diabetes or another ailment, there is a need to understand what comes next, just from a personal perspective of planning around this. So this is really what we're striving to do here. We're not just predicting costs, but we're predicting how your condition would evolve, and as a result, what services you may need, and what is the cost associated with those services. What we also help the members in trying to identify providers within their network that would help them to really be able to take care of a certain condition that they have, keeping the cost in mind, but also the quality of care. And it's very interesting to see the quality of care from a cost perspective. You can go to a specialist for something, for some symptoms, and order you to go for a colonoscopy right at the get-go. Under my current health plan, a colonoscopy around the Boston area would cost me an average of $4,000. Is that really good quality of care? Why wasn't a blood test suggested first? So this is how we guide the member to say, usually the specialist ends up having better outcomes at more cost-effective services than others. And finally, really, is trying to help recommend the best health plan to be on, given what is predicted for the future. The best basic health plan, as well as any supplemental insurance that you should be on so that you mitigate your own risk against your healthcare needs. The interesting side that I found about working with this are, and the things that I have learned are enormous. First of all, it's big data, which means that some of the algorithms that we had been taught did not really work in that environment. There was a lot of care in how the data structures are designed, how the databases are best to operate, how to make sure that this is still responsive for the user, and how to make sure that actually our machine learning, but also our optimization is designed carefully and effectively to deal with the number of data that we have. Another aspect was, in that design, security is a very important component. So HIPAA compliance all of a sudden became a really important and integral component of our software development and how the algorithms are hosted. When do we deal with PHI? How do we destroy PHI in the process? And that was a very interesting component. And then at the end, I did mention it. We are trying here to help users. And if you don't cast the insights and the analytics-driven recommendations that you're sending them in a very understandable manner, we have lost their attention. We're pretty much not doing anything better than what's out there for them currently that would help their case. I'm really excited about what comes next for us. We are right at the stage of now hitting the market. So this is really an interesting side of monetizing on all the algorithms that we've done and creating all the service offerings, if you will, that what we've done. But we believe that this is something that might be very useful for people, and we hope that we're going to do it right. So thank you very much.
So our last speaker for today on the topic is Vijay Chandra. Vijay has graduated from MIT more years than I have, not too many though. Yeah. And today also, it's the 65th anniversary of the OR Center. It's also his, not today perhaps, but this year is his 65th birthday.
Right, thank you. Thank you.
He's a professor at, he's both at Strand and the Indian Institute of Science. Vijay?
Right. Thank you so much, Dimitris, and thank you for including me in this, and it's wonderful to be back here and with all of you. I'm particularly delighted that Dick Larson, Tom Magnanti, Professor Little, these are all people who played such an important role in our education. And I do miss Jerry Shapiro. He's not with us anymore, of course, and but I think Jerry was one person who actually, in addition to all the mathematical programming education that I got, I think gave me this courage to be fearless about going into new areas and new applications, which I think has actually served me well, or at least I hope it has. But I think what I'd like to focus on today is sort of mostly the story of Strand Life Sciences, because I think it fits in with the session, of course, and also I think it's it's the it represents in many ways the evolution of the whole field of computational biology, which we've sort of gone along with, and and I think please forgive me if I'm a little incoherent. It's 2 a.m. for me. I just got in here last night. But in any case, let me jump in. I think I use the title, it's genomical, because if you, I think about predictions of where the amount of data that's going to come out of genomics and molecular biology, it is felt that this will be dimensionally, comparable to or even larger than what comes from astronomy. So maybe the Webster Dictionary will redefine its astronomical to its genomical, right? This is what the University of Illinois guys titled their paper on predictions of where genomic sequencing is headed. And of course, I think I very much appreciate the perspective that Dimitris has been presenting on how sort of operations research and modeling to decisions can actually play a very significant role in this field. And, so I think analytics in a broader sense is where this is at.
The green button.
The green button. There are two of them.
The top one.
The top one.
Big one.
Okay, there we go. Just to give you an idea, I guess the Indian Institute of Science is, it's the institute in Bangalore, and where I went back to teach after studying at MIT and then teaching at Purdue for about 10 years. I went back in the early 90s, and in some sense, the MIT culture that I went back with helped me to conceptualize and become an entrepreneur while being an academic. This was the first time it was done in India. So, back in 2000, when Strand was created, this was actually the first instance of academic entrepreneurship in India. And since then, of course, there have been several others, but that was a significant step. And I think we were actually 4 professors who were all founders when we stepped out and created Strand. Strand today is a significant player in the healthcare space in India. We actually are amongst the top 5 diagnostic chains in the country. We do a lot of diagnostic tests, and actually have an interesting mix of mathematicians, computer scientists, life scientists, geneticists, and a significant number of clinical people as well now. What we do is a mix of bioinformatics, clinical diagnostics, and clinical research. And I think the bioinformatics part of it, the analytic tools and services for research, is actually a very significant part of what we had done. For the first 10, 12 years, Strand really focused on building these tools. The situation was that, the Human Genome Project was in an advanced stage by about 2000, and it was very clear that, they were going to need better tools for annotating the human genome and for analyzing high-throughput experimental data that was coming out of measurement technologies. I'll skip that. So what we did was actually built the analytic tools, which then have been used by the instrument companies and distributed around the world. So it's there are platforms like GeneSpring and so on, which now reach thousands of labs, which actually came out of these technologies. Now, I'm sorry, I think a slightly different presentation found its way here, but that's okay. Let me skip through some of these. I think I got a much larger presentation over by some error in the email. So as I was mentioning, I think essentially these measurement technologies of high-throughput microarrays, mass spectrometry, and next-gen sequencing, and so on, were actually having had come onto the scene and just needed better techniques for analyzing the data. This is a far more detailed presentation than I had intended. There we go. And the red button takes me back, is that?
I believe so.
Yeah, sorry. So today, essentially, these diagnostic labs are spread all over the country, and it is, we're able to serve about half the nation today from these labs. In terms of impact, of course, finally, it is these patient stories that really stand out. I think, as Dimitris was just pointing out, I think the two areas in which there's a very large impact is cancer, oncology. So a big part of our focus has been on oncology, and part of the reason we have such a widespread network in India is that we have a strategic partner, a network of oncology centers, which are a bit like the Cancer Centers of America. These are like 31 hospitals spread around the country, which sees about 51,000 patients, new patients every year. So the ability to now scale the diagnostic tests and bring in precision medicine in treatment for these patients has become significant. And let me, oh, there we go, sorry. So the challenge in diagnostics for oncology and for precision medicine is, yeah, thank you, is that, fundamentally you have, let's say, a few thousand mutations and variants that show up when you do sequencing using a multi-gene panel. And then out of these thousands of variants, you have to essentially narrow down to the specific variants that may be driving the disorder. And then you have to match those specific variants to treatments that are personalized. So that, and essentially what you need then is technologies that can condense all this knowledge and bring it together so a report can be generated which meaningfully matches up these variants with the treatment decisions. And these are, essentially involves various ranking algorithms and sieving techniques which have to bring down and narrow down the search to the relevant variants. And again, the algorithms and the ability to come up with the right decisions is very important. And finally, we've also put a lot of case studies together, and my co-founder and computer scientist, CEO now of the company, Ramesh Hariharan, has put this together in a very nice book, which is available on Amazon right now, and it will be in print shortly. Actually shows how the search for the pathogenic variants, the diagnosis decisions, and the treatment decisions come together. I'm sorry, I think the presentation didn't quite match with what I had actually prepared to speak about, but let me just summarize by saying that I think the use of machine learning and predictive technologies have to be incorporated within these platforms. I think the final decision making today still rests with the physicians, and so there's also a huge education or continuing education that has to happen between the analytics community and what we put together and how to get physicians to change their guidelines. And essentially, here there is a need to put together outcomes work, to do far more work with on the clinical research side. And of course, I think there's great momentum in that direction, and we should see the impact fairly soon. Right. Thank you.
Thank you.
Right.
So we have 25 minutes for questions. Fire away. David?
So, following up on the theme of education and what we can do to help doctors as part of their medical training have better analytics. If you think back to their pre-medical school training, medical schools in their quantitative training require typically one course, calculus. And I would posit that if we want to think about where we should first make goals, it would be as beautiful a subject as calculus it is, that isn't perhaps the right quantitative training at the college level. Any suggestions for how we would go about affecting the American medical school's views of what is the right quantitative training at the pre-medical school level?
So this is something I thought about, and I had several meetings with the Dean of Medical School at Harvard. Personalities matter, as you know. The current dean at the Harvard Medical School is much more amenable to suggestions. I also believe that calculus is not really needed for medical doctors. Mostly it's really a cultural component. It's not exactly what you, I definitely believe machine learning is relevant. Not the deepest and the greatest, things that work with medical focus. In fact, the class I have been thinking about is something along these lines. Relatively French principles, because they really don't have the background. And ideally, should be taught earlier. But that's the opportunity you have, that's the opportunity I will try. But I actually believe the new college, that's yet another reason of my excitement, is that this new College of Computing will have the opportunity to redefine and redesign some courses that, even though MIT does not have a Harvard medical school, it doesn't have a medical school, but it does have people who go on to careers in medicine. So that could be the opportunity. In my view, starting with machine learning algorithms with a medical orientation, that's something immediate for me. That is, it would be easy to convince. And if you look at the interest of the medical community, reluctantly, if you look at papers in the medical community, they are now starting to have some type of machine learning. Perhaps not the New England Journal of Medicine, even though it has some articles, but there is interest in that area. So I definitely believe that the landscape is changing, and we collectively can accelerate that process. That's the best I know.
Can I
I'm sorry.
Sure, no, please.
Yes.
Go ahead.
I want to mention that more than education, I feel that physicians are having a lot of software to work with. So even if they were trained in analytics, it's not like they're going to pop R and then run the analytics. The insights from the analytics, first of all, it's them accepting that this is a decision support tool, that we're not replacing them. Right, this helps their 15-minute visit, basically with the patient. But it has to be supplied to the electronic medical records. It has to be embedded in their process. Otherwise, they won't look at it. They will not open an additional dashboard just to look at it. So it has to be embedded within their process. That would make it much easier for them to adopt it.
Right. So I think this whole business of physicians being able to understand how to make decisions better. Actually, when I was a student here, one of my classmates, Josep Valor, did the MD PhD program with HST, and I think he actually focused on decision making in the clinical community, and actually found how in some sense, they needed a lot of training to think about rational decision making in a very different way. And I think the physician community, to a large extent, believes in guidelines and believes in best practices and so on. And I think, finally what seems to make a difference is that thought leaders within the physician community have to stand up at their conferences at ASCO or wherever and essentially say that, these are the new guidelines we've been following. These have, worked well for us. Here is the outcome data that presents this. And then there is, in some sense, the community sort of follows the new guidelines. I think that change management within the medical community is, is a slow and difficult process that has to come about. I think in education, I would dare say that the younger physicians today are already, much more open to learning from data and learning from the new techniques. But I think there's still essentially the health establishments are still conservative in the way they approach. So I think.
Although I am more optimistic, just to give you two examples. Okay. One of our first students in the second year MBA, Master of Business Analytics, was a medical doctor, age 34, who is now at Children's Hospital. We wrote papers on utilizing, he's a urologist, utilizing that, and the enthusiasm and the understanding and so forth, he brought it there. I can see a change. Second example, in the American Journal of Transplantation, one of the arguably the top journal of transplantation in the country, had a writer to write about machine learning in transplantation. I think the train is moving, and we can affect the direction. Dick, I'm sorry, Rezef, afterwards.
Hi. No, it does work. Lots of data, lots of data. These are ubiquitous. These tell all kinds of health things, like number of steps you take every day, the speed via GPS. The Apple iWatch now can give electrocardiograms. So I guess my question is, everything I've heard, which is extremely impressive, is response to disease. But what about prevention and or at least early detection? Because with the data we have, and we could even have grocery receipts, if we put all these things together, they're all correlated with health status. I even hear that there's a technology now that analyzes human waste in the toilet and can detect early disease that way. So instead of responding to the fire once the fire starts, I think of what's going on in California, why not these preventive things and use the ubiquitous data that we all have or new inventions are created? So that's the thought.
One response I have, I didn't mention it, but the group here works on what I call jumpers for major diseases. Let's take diabetes. We have data from the Truven system that has about 100 million people. And take, for example, somebody who is at a level of maybe $2,000, $3,000 a year cost, but it's given we see what's going on, is predicted to become a diabetic or have very high blood pressure and so forth. So early detection. So I think these techniques can also, and we are, us and others, work on this topic. I do believe this is important, and it might be even more influential, as you mentioned, than treatment. Prevention in many, to this day, oncology prevention is the best way than treating things that we don't fully know how to treat. So it is there. There's a sizable amount of activity. I mean, I know, for example, John Silberholz at University of Michigan works on personalizing treatments for various not treatments, personalizing checking, like what kind of exams should you have for various human diseases before prevention, before treatment. I think this is another great area, and we just didn't have time for it.
So I think preventive healthcare is obviously a huge topic, and and certainly the wearable devices that you mentioned and are going to play a major role. I think societies like China and India are certainly going to have to focus on preventive healthcare. I mean, just the numbers of patients and the affordability issues are going to essentially force healthcare to take a very different approach there. I do believe the interesting thing that we are seeing in the West is that the payers, the insurance community in the US, for example, is starting to play a role. So, in fact, I'll be traveling to Minneapolis to meet with the United Health Group there, and some of the work that they are doing with diabetes, for example, and wearing continuous glucose monitoring. They have about 10,000 individuals now who are pre-diabetic, and they want to see if they can monitor the glucose on a 5-minute basis for about 10 days, along with Fitbit data and and sort of recording of meals and so on. So to be able to then suggest lifestyle changes or medication changes which can actually regulate blood sugar much better. So there are many such experiments going on. With another project that we're doing with United has to do with the microbiome, as you were talking about. In this case, not waist microbiome, but vaginal microbiome and preterm births. So being able to actually predict preterm births based on vaginal microbiome. So I think there's a lot of very interesting work going on in these directions, and they all point to the effectiveness of preventive health. Actually, the RAND Corporation guys had built a very interesting simulation model called the health, it's called THEMIS, THEIMS. And it's a simulation model that is an economic simulation of health innovations, right? And they actually did a simulation, and there was a paper in Lancet about a year ago, which showed that if personalized medicine and precision medicine is used for preventive healthcare, the kind of economic impact it could have would be enormous, right? For chronic diseases and not just for cancer. So, right.
Let me add a perspective as well of behavioral. A lot of the preventative aspects that we are talking about require lifestyle changes, people thinking or patients thinking more long-term rather than short-term. There's a very interesting article in the New York Times with the rise of high-deductible health plans showing that people are not going to their doctors frequently because they are afraid of paying more than their copay. If you go to your doctor under a high-deductible health plan for a specialist visit or primary care visit, you might be paying $250 instead of $25. And so while the system is saying preventative care could be free, so you should go there every year for your routine checkup, if you have any symptoms, people are just staying, not going, thinking that I could save for the short term, not understanding that this may result in an emergency room visit and potentially a chronic condition that is not manageable, that into the future would actually be very costly, not only to the system, but to you as well as a patient. So there's this one component. There's the second component, and you mentioned United Healthcare. Payers are trying to figure out how can I direct patients to the right action to basically really slow down a disease. And let's talk about diabetes for a second. It requires diet changes, exercise, and a completely different lifestyle change. If I work 2 shifts quite frankly, this is the last that I want to know about cooking, nice food and having something potentially delivered to my house, et cetera. So there is the behavioral component of the patient that requires more than just the payers finding the right services and incentivizing people through designing their health plans and what is free and what is not free, but also a conversation with their healthcare provider, maybe a health coach, that would also take into account the behavioral components. At the end of the day, the way we react to a certain diagnosis may be very different. And it's definitely research in that direction for diagnostic procedures is very interesting, but it's also, do we get patients to actually go and do them? And would they react to something that says, if you continue this route, you're more likely to develop X, and this is going to cost you Y?
Richard?
If I look on the time from inception to implementation, the time allocation was something like that. It took like several months to 6 months to get the data. It took like about 6 months to develop the model, and then it took like between about 2 years to implement the IT solution that can be operationalized. And I'm building maybe on what Natalie said before. It seems that currently the IT systems in most health systems at least are not, to say the least, are not welcoming external add-ons of analytics or any kind. And in my experience, this is a big inhibitor that if we want to accelerate the pace of adoption, we will need to address that in any way. The question that I have is, are we an active part of trying to solve that problem? Or are we making a decision that we're going to wait until others will solve it and just then play?
Want to take it?
I find this a very interesting question because apart from Reclaim My Health, I have worked with the Yale New Haven Hospital. And it's very interesting, just as you mentioned, it took us more than a year to get the data that was already in the system. They've already had the query, the right query to get the data. But it took so many months to even get into the priority in the queue. I believe that I see the issue being two-sided. We have let some electronic medical record companies go very large to the point that it's really difficult to negotiate any stake, right, in terms of having an add-on, because the first thing that they will say, well, we'll create it ourselves, right? Or we want to just buy it and just embed it in our system. At the same time, we are faster at implementation, definitely with smaller teams, or if we're doing research, which we're much faster at implementation. But then getting it into the system is such a big hurdle. And as I was mentioning, just doctors aren't going to have another dashboard run. They already are copy-pasting from one dashboard to the next. And it's really difficult for us doing the algorithm part, not to think also about the delivery of the entire, it's not really, we were hoping to have it as a plug-in, but it can't be fathomed as a plug-in because we're gonna lose the intellectual property behind it, et cetera. So then the question is, we can't also create a whole standalone system because that requires many years, and there's, hospitals have invested billions of dollars in these software systems that they currently have. I wonder how much we can do on our side other than being really a proponent for standardization of data, democratization of data, and really maybe having thought leaders in our community lobby for such ideas, showing that actually democratization of data helps patients. And maybe that way we can move the needle. It's very difficult to do it on our own.
Maybe another question, Rama? It's not that this doesn't deserve more answers, but...
Very exciting stuff, by the way. And Dimitris, your vision for, excuse me, personalized medicine is very, very inspiring. So my question is, I assume that each of you is working on the most promising idea that you can think of in this arena, analytics for healthcare. So that said, if you had ample access to venture capital, which idea would you go on if you were not doing this? And again, just to be very clear, full disclosure, I'm fishing for startup ideas. So.
Well, first of all, Rama, you know my views on venture capital. Ladies notwithstanding, I've never used it. So, but assume you have infinite resources somehow. Yeah? In my view, I will put serious effort on oncology because there is understanding. Let's take melanoma, for example. Melanoma, the most exciting development in the last couple of years was, and it's very small in the scheme of things, but elongates life, a particular immunotherapy for particular mutations by about 6 months. It's not, but there is understanding, there is evidence that there is promise there. I have seen with my own eyes, not hearsay, that the ability to have, with the broad institutes near us, they have sequenced many, we have a lot of information on that. I believe that utilizing our methods applied to the data that is increasing, it's only recently that this has been going in such large scale, I think the future is even not 35 years, fewer years. To be honest, I don't know if the constraint is money. If in my experience, it's not the binding constraint. The binding constraint, again, other people might have different experiences. I'm telling you mine. My experience is not money. It is to be able to scale what you have done and convince others, particularly the medical community, which is conservative, you know, it's difficult to convince, this has been my experience, to scale what we find, recognizing that what we have is not perfect. I mean, you know, there's no perfect paper, there's no perfect algorithm either. But something that works 70% of the time and saves, let's say, even one person is worth doing. And now, whether this would translate to economic advantages that the venture capitalists would like to, it's a matter to be seen. But there is, there's a company nearby called Moderna, recently, Strand is another company in the space, that there's serious venture money on this space. I would say my bet is that as far as human outcomes, human life, my bet is oncology first, primarily because there is evidence that it is working. That's my...
I think the two most exciting areas that could be bet on are oncology, but I'm very excited about liquid biopsy. I think it's something that we talked about this morning, because I do believe that being able to detect cancer at early stages, is going to make a huge difference, and the impact of that is going to be phenomenal. And again, as I was saying, China, India, I think, will be countries that will be hugely impacted. China now has declared that it sees 4.1 million new patients in cancer every year. Their registries are now getting much more thorough. India is probably comparable, but actually the registries only show about 1.2 million today. So these are huge numbers, and unless we detect the cancers early, it's going to be very difficult to treat patients. So I think liquid biopsies, today we are able to detect about 20 to 30% of varied cancers in stage 1C to about 2A, right? So it actually, is working, but I think we need to get those numbers up. I think GRAIL is doing a 12,000 cohort study for early breast cancer detection using liquid biopsy. So I think that's probably a very exciting space. I think on genetic disorders, and I do believe that there is gene therapy is very exciting. I do think there's a huge problem there with the manufacture of viral vector, which has inflated the costs quite a bit. I think as that scales up and the cost economies of scale come in, we're going to see gene therapies at a much more affordable price. And that, again, can have very large impact. So
let's take one more question. That would be the last. I know we are a few minutes ahead. If not, thank you, Patrick, for reminding me. I said one more question, if any. Now that you said it, nobody wants to ask.
That's a great strategy.
Great. All right. I thank my fellow speakers. And we are moving ahead on the last panel of the day. My colleague Recep Levy is leading it.
So we'll take a 30 seconds mental break. So. Okay. So as we were designing these 2 days, it was very clear to us that we need to have at least one session or panel on military and security applications of operations research. And I think there are at least 2 reasons for why this is maybe a must in an anniversary of the Operations Research Center. And let me talk about these reasons and also use that maybe to share a few thoughts about operations research and maybe relate to some of the things that we discussed throughout the day today. And then I will introduce 2 great speakers and let them speak. So the first reason, I think, is that if you actually think about that, the origins of operations research are rooted in military applications, starting with World War. Yeah.
They go change the tags on the seats there for us.
They get what?
The name tags.
I don't know. I'm good. People know you, I guess. So. This is Tauhid and Eric. This is not Dimitris, if someone gets confused. Okay, so the very first both applications of operations research, and actually the very first group of operations research was created actually in the UK in the military, where the context was the integration of radar technologies into the military. And since then, military applications of operations research have just expanded to include anything from planning a train schedule to the front lines, acquisitions, maintenance, inventory management, supply chain management, and so forth. And it's also fair to say that the military, or most militaries that I know, I spent almost 12 years in the Israeli military, have operations research units and functions. And it's basically quite an inherent part of military decision-making processes. Things become more interesting when you expand the notion of military applications to more generally talking about security, homeland security, public security, in the context of cybercrime, other crimes, food security, and so forth, where essentially if you actually look on the organizations that are responsible for those aspects of our life, the notion and the familiarity with the operations research discipline is actually far, far less advanced and in some cases non-existing. And also the nature of the applications is very, very different. Even if you just think about military applications, traditional applications were focused on an enemy that was another military or another country that has something that is very structured. It's an organization that has a hierarchy, has clear decision-making processes, and so forth and so forth. Many of the current applications deal with individual terrorism, individual crime, and things become far more messy because it's something that requires you to actually follow individuals, and to make things worse, It's following individual within a very noisy environment, since these individuals typically operate embedded in systems that are used for many other communications, like the internet, social networks, and so forth and so forth. And that actually brings a very, very different set of challenges to how to use data and operations research kind of discipline to actually guide and inform decisions. So it's really a different operational challenges that militaries are facing currently, maybe not even very recently, like over the last 2 decades, but it's becoming more and more challenging because of the advancements that we have with the way we can communicate. And as much as we benefit from this as society, that also gives opportunities to people that are not well-intended to use the same infrastructure, same technologies, the same advancements to actually do bad stuff. So that's the first point, and then the second point that I would like to mention is a reason why it's a must in an anniversary of the Operations Research Center to talk about military applications is the training aspect. I'm not sure if everybody is aware, but the Operations Research Center on a regular basis over many, many, many years is training officers from the Air Force, from the military. We are admitting every year, I think, between around 4 to 5 students from either the Air Force or the military academies into the master program that we have here. We actually have a few former PhDs that came back. In fact, one of them you're going to get to hear from just very recently. I think that our more senior graduate in the military is a one-star general in the Armor Coast. But I expect that over the years, we're going to get more senior leaders in the military that were basically trained in the ORC. And I think that that's another channel that the ORC has been making a major impact on through operations research, through education on the military in the US. So putting it in a more global context, and it's public information. So I can tell you that the Israeli military very recently started on top of operations research units, it put together a new unit on data sciences. And I think that, I suspect that that's going to be a trend that's going to see in other militaries and other security organizations. The opportunity that might be lying in front of the OR Center and is whether we can play a role in educating and training more people that will go to those kind of units, and what is the overall opportunity that we have to actually make even a bigger impact through education and potentially even through collaborations with research. I can tell you that at least in the people in the Israeli military that I talk to, there is a very, very significant thirst both for education opportunities as well as for collaborations, because the challenges are tremendous. So today I think we're going to hear 2 talks that in many ways address some of the issues that I've discussed before. The first speaker is going to be Eric Zarbinsky, and he's very unique in at least several ways. First, he's one of our, I guess, 2 PhD students so far, right, that we had?
In the Air Force, yeah, I think that's...
Yeah. Is it 3, maybe 3. But one thing that is definitely unique is he's my first PhD student that I graduated. So, and together with Tom, I still remember Eric come to me on the first day and say, I need to graduate in 3 years. Can we do that? And I said, yeah, why not? And it worked out. So he's going to talk about military applications, and I think that one of the things that he will talk about is connecting very substantially to some issues that we covered earlier today that really distinguish between operations research and machine learning. And that is that the focus on decisions and the focus on decision processes. I think that one of the gaps that we see is that most people that understand decision processes do not understand data and machine learning, and vice versa, most of the people that do machine learning today do not understand decision processes. And in the military, the notion of being able to incorporate what you do into a decision processes is really key if you actually want to use that. So I think that that's going to be a point that will be significant. And the second aspect that Tuid is going to talk about new challenges that emerge in the context of terror and crime activities hidden within big social networks and communication, public communication networks. And again, another aspect that will emerge there is the notion that a lot of the data that we use is actually generated by some physical system that has some underlying processes and context that if we don't incorporate that into our models, we're going to miss, and we are likely to miss in a big way. So without any further delays, I want to welcome Eric to be the first speaker.
Okay, good afternoon. First of all, I will date myself. I had no idea there was a new ORC logo, so that's why it's not included on here. So that tells you how long ago I was here. First of all, so I am from the US government and I'm here to help. That requires me to say, these are my views, not the US government's. Okay, got that out of the way. So I'm going to talk about two examples of kind of non-traditional OR applications. So as Retsef mentioned, the military has been doing OR for many, many years. Most of the applications that you are familiar with, transportation, logistics, those kinds of planning aspects. These are two slightly different topics that I think will draw out some good lessons learned. And again, it's getting back to those decision making. And then I'll have some kind of parting thoughts about why OR in the military is somewhat unique. So let's start with the first one, facility location, and there's a reason that the facility is in quotes. So at the end of the day, that's my customer. Troops on the ground, in harm's way, I've got to support them. So I spent about 7 months in the Middle East supporting these guys every day, making sure that they were taken care of. So what does that have to do with facility location? There's my facility. There's another one. The question was, where do I put aircraft in combat air patrols so that I can respond to troops on the ground as fast as possible? This has real consequences, not only for those troops on the ground, but our national security as well as their families back home. So, interesting OR application that no one had really thought of this as a facility location problem. It had been looked at just as where are the most amount of contacts, where are we seeing the most amount of activity, let's just put our aircraft there. They hadn't stepped back to understand what's the real problem I'm trying to solve and what's the best way to do that. Back to some of the discussions earlier, lots and lots of data. We had a huge database of all tactical engagements that had happened in country by location down to basically a grid square, as well as the date and time. So a massive amount of data that we had to understand. The second thing we built early on was a predictive model of what's going to happen in the future. If I'm going to look at placing aircraft overhead, I need to be able to kind of look into the future and understand about what I think is going to happen. Pretty obviously, there are autoregressive terms, days of the week, months, holidays, many other aspects that we brought in this predictive model to try to understand where do we expect that next engagement to happen. Okay, so I know earlier we talked about Hiller and Lieberman. I thankfully had brought over my urban OR book when I deployed, and I said, I know what this problem is. I know what I'm going to go do. So the first question was, what am I trying to optimize? So am I trying to minimize the average response time? Am I trying to minimize the maximum response time? Or is it something different? And I'll tell you the answer is it's always something different. And we'll talk about that in a second. The other part was the requirements portion of how many aircraft should I have on standby every day to go off and respond? So in a given day we set up and there may be 6 aircraft, and that's just given the units that are deployed. But in the future, I might be able to make that to 7 or 8 or 10. But I need to be able to explain to a decision maker why that matters. Why should they deploy more people downrange in order to support the Army? Second interesting part was the independence assumption. You know, one of the underlying assumptions of facility location, that these are independent. I can always service my customers. Well, there's only one aircraft. If it's off servicing one customer, it can't necessarily service another one. The homogeneity assumption was also difficult. So as you saw, I had different kinds of aircraft. They don't respond at the same speed. They have to get refueled at different intervals. They weren't all the same, so we had to deal with that. There's also airspace considerations. While you may imagine you can go from point A to point B directly, it's not quite that easy. There are things called artillery that are coming through in certain zones. You can't fly directly through there. So airspace considerations were also something we had to think about. And finally, other restrictions. This is where the fun of the military comes in, where Marines really like to support Marines. Maybe not the best answer from our model, but sometimes we had to consider that, well, the Army really likes this unit, and that general officer is going to ask to be supported by this type of aircraft. You've got to think about those and model those. So what do we do? This is another great thing about the military. I did not have access to AWS, didn't have a supercomputer. I basically had the laptop computer on my desk. It's all done with VBA because that's what we have. The military, in the environments we were in, you don't have access to all the powerful solution algorithms we talked about earlier. We also had to build a graphical user interface because at the end of the day, I'm not the customer of this tool. It is fighter pilots that are on the floor every day making decisions of where to put aircraft. And this had to be usable for them as well as have the deep analytical reasoning behind it. Finally, it's got to have flexibility, usability, and the users have to have confidence in it because this changes all the time. What aircraft come into theater changes every 3 to 4 weeks. The guys on the floor who are using this tool would change on a regular basis, and they need it fast. They need a solution in 30 seconds or less at the most. So this couldn't be a large churn through a bunch of data and spit out a solution a day later. This had to be made in real time as things changed on the ground. Okay, so what are a couple takeaways? I think the first one we've talked a lot about today. Solutions are important, but insights were actually more important. So when one of the guys on the floor could sit down and say, oh, I understand why the algorithm put an F-18 there versus a B-1, once they could start to think about this, the tool was just supporting their decisions, but it was really helping them get those insights. The second one is nobody knew they needed this tool. There was no thought process of, hey, I need to understand this as an optimization problem. So as I got in there, it was understanding what their actual need was versus what they were telling me, which was build me a better widget. And finally, user documentation in the military is hugely important. People change out all the time. My deployment was 7 months. I left, I have never gone back. And the next crew comes in, and the next crew, and the next crew. So you have to document the front end as well as the back end so that these can be maintained. If not, much like the question earlier, how do we maintain code? We ran into this issue quite a bit. Okay, let me talk about a very different problem that the military thinks about. So for commercial communication satellites, this is a very easy question to answer. When the XM satellite radio satellite starts to go down and have issues, they build a new one, they launch it, life is good. What happens when I have a constellation like GPS back that would enable those wearable technologies? When do I replace a GPS satellite? So the first thing is the mission capabilities. So for the GPS constellation, this is a pretty easy question to answer. I need accuracy of a certain amount down to a certain number of feet. That requires a certain number of satellites, an easy question to answer. There are many mission areas where this question is much harder to answer and is very important to think about. The second part of this methodology is, what's the current status of my satellites? I have a couple of fully healthy satellites, some that are not so healthy, and some that are on their last legs. Finally, we think about the component reliability. So some of these components, some of these satellites, they've been on orbit for 20 or 30 years. Trying to estimate the reliability of those components going forward into the future so we understand how long those satellites are going to last. And finally, when are we going to launch the next satellite? So this is an input into our model to understand when our future launch is going to happen. Pretty straightforward, not a hard thing to go off and run a Monte Carlo simulation. Quite large, takes quite a bit of time because of the size of these, the component reliability, we're estimating thousands of components on these satellites and running them out of 30 or 40 years. And what happens, what comes out of this, is a prediction of whether or not we're actually meeting those mission capabilities based upon a probability. So this is just an example result. You can actually go out and find this on the web. This is what gets submitted to Congress every year that says, what's the probability that the GPS constellation is healthy? And this is how Congress makes its budgetary decisions of when the next GPS satellite's going to launch. Is that important? Well, I'd say from a dollar figure, yes. One launch, even if you're going to buy the lowest end of a SpaceX launch, you're talking about $90 million. A GPS satellite runs on $300 million a piece. So these are very large decisions that are being made from this data. So this is where an operations research mindset can really help. Determining the right mission capabilities, again, very straightforward for the GPS constellation. For other systems, it can be a lot harder to understand. And you have to make it comprehensive enough that it matters, but simple enough that we can model. The second one is trying to explain to decision makers that probability threshold you saw on the previous chart. You can move that down a very small amount and it drives very large changes to the future predictions. And that's something that isn't necessarily intuitive to some of the decision makers. The other key we had to drive home with this is it's probability, not prediction. Everyone wanted to know, when is that satellite going to die? Because when that one dies, that's when I'm going to launch your next one. And it's important to get through to the decision makers, especially earlier talked about some of the younger staffers on the Hill, explain that that's not what we're trying to do. We're trying to understand what's the probability we can actually meet these requirements. And the final one, and one that's gotten a lot of discussion in the last 6 months, is this is all predicated on a benign environment. What happens when space becomes a warfighting domain, and how do we modify this result, these analytical results? Okay, so here's a couple of just parting thoughts on military OR that I think I've found true across the number of projects that I've had. One, commander's intent drives our assumptions, our inputs, and basically everything we do. It's kind of back to that contextual modeling that we talked, contextual optimization that we talked about earlier. The commander's intent is going to drive what we do and how we implement what they want done. Quantifiable objectives are hard to come by because that's not what commanders think about. An Army unit, a division commander isn't going to come in and say, I want you to minimize the average response time. The answer I usually got when I asked that question is, well, I want you to minimize the average response time, but nobody can have a response time of over this, so make those both happen. I'll get right on that, thanks. And finally, the great quote by George Patton, and this I found true across my time, both deployed as well as back here in the US, I need an answer now, right? An answer after I submit the budget, an answer after I deploy a unit downrange isn't any good to me. So get me an answer now as good as you can. I don't necessarily need the optimal solution. Thank you.
So any questions to Eric? Yeah.
Maybe one question on the final quote you ended with. Have you found sometimes a good plan executed now standing in the way of a perfect plan being executed the week after when it would have been ready?
So I think part of that discussion becomes understanding what those time thresholds are. So there are definitely instances where we said, I can get you a good answer today. If you give me a week, I can get you a better answer. And it was an active discussion with those decision makers to say, well, when do you really have to make a decision? I think that's part of the conversation we continue to have with them is, I know you want something today, but do you really have to decide today? If the next deployment isn't for 6 months, let's get you a better answer. But if you're sending guys into the field in 30 minutes, I'll get you an answer in 30 minutes. So I think driving decision makers to understand when they have to make a decision versus as soon as possible.
Yes?
What do you think is the value and possibility of having something other than VBA downranges?
I think there'd be pluses and minuses. So part of it is I think it might drive analysts to go more complex than they necessarily would need to. I mean, these were relatively straightforward problems, especially the fighter allocation problem, relatively straightforward to do in VBA. It would open up some possibilities of better answers. And I think back to the previous question, right? I could get you a better answer. Is it going to necessarily change the decision? That I don't know.
Yes?
How did that model differ from conventional operational practice? Were there any kind of major insights or major kind of decisions that were made post coming up with, I'm talking about the fighter model.
So I can definitely tell you there were decisions made because the allocation of aircraft was driven by this algorithm, by this implementation. So they did change and use these. Were there drastic changes? No. The intuition was pretty close in that if I know that there's a lot of activity in one area, I probably am going to have an aircraft close to there. What really became the bigger change was which aircraft you assign to what locations, because so again, an F-15 is very fast but has to refuel often. A B-1 has a much larger carrying capability for munitions. So some of those decisions did change because we were able to consider them in the model where the kind of day-to-day operational folks had not necessarily thought about those second and third order effects.
So I have one question. So you mentioned the optimal solution, and you also mentioned multiple objectives. So to what extent the optimal solution is something that was invented by academics? My experience that most decision makers would like to see trade-offs and would like to understand trade-offs rather than what is the optimal solution that often just doesn't exist other than maybe in our models.
And I think that my example of the objective function is exactly what it was, is they couldn't say, hey, I want you to minimize the average response time. It was, well, I kind of want a little bit of everything. So I think their optimal solution was definitely less important than I'm meeting what you think you need and I'm doing better than what you were doing before.
Yes, Ali.
The question about the interface between the human and the algorithm. Yeah. Do you think as OR practitioners are well equipped to kind of think, design, and think about the human interface? What are the unique challenges that face military coming up in those interfaces?
So I think the military definitely has some pluses in that most folks are very familiar with PowerPoint and Excel, even our fighter pilots. Because they're kind of forced to have to do that. Now, the algorithmic back end, I spent a lot of time on the floor with the air controllers to explain what was going on and get their feedback of, okay, what could I show better? How could I do this better so that you understand what's coming out of the algorithm? I'd say it was a lot of trial and error. I thankfully had a lot more time there to work on it. When you're working 16, 18-hour days, you get a lot more time to do things. So I could spend a lot of time with them and get a lot of different perspectives, but I will not say the first thing I walked down with was the right answer, because it was a lot of iteration. Yeah, I think that it.
Okay, let's just thank Eric again. And next, I would like to invite Tohid Zaman, who is a faculty here at MIT Sloan and affiliated with the Operations Research Center, and he will talk about some cool and innovative stuff on how to find bad guys that are hidden in social networks. So, Tohid.
Cool. Thank you, Redsef, and thanks to the ORC for having me here today to speak with you guys. So I missed the last panel. Did anybody make the joke that the ORC is not eligible for Medicare because they're 65? No one made that joke? Okay. Appropriate over that section. Just a little disclosure here. So I'm not an ORC graduate. I'm a MIT ECS graduate. But I knew the ORC kids when I was in grad school, and they're always like really smart, cool people. And now that I've mentored a bunch of them over the past couple of years, yeah, these are like really impressive kids. So kind of an honor to be mentoring them. And Redsef, you said your first PhD was Eric, who was in the military. Well, my first PhD student was Chris Marks, also a military guy. So we got that in common. So I think that's why I'm on this panel today to talk about national security, because I'm like Redsef got experience in the military, Eric does, but I'm a civilian, right? Like, what do I know about military stuff, national security? What I know about is like social media, Twitter, Facebook, Instagram. And it turns out in the past couple of years, that stuff is important for national security. So the title of my talk, the formal title is Operations Research and National Security, but the fun title is From Tanks and Bombs to Tweets and Bots, okay? So what does this talk about? Where's the forward button here? Got it. Okay, so, I mean, we all know OR began in World War II, right? I think Ed Kaplan told a couple of cool examples of like how they applied OR in the war, like, you know, to find the U-boats, they figured out when they should like detonate the depth charges to blow those things up. They said, don't do it 100 feet, do it like 25 feet, like shallower depths. That's an OR thing. For their planes, they figured out if they paint them white on the bottom, they're like less visible to the U-boats. So like, this is like OR thinking in its genesis to help these tactical decisions made by the military. And then since then, OR has kind of penetrated all over national security problems. Yeah. So for like assessing the operational capability of a tank or other kinds of weapons, that's an OR kind of thing. To figuring out like what kind of fleet to have, allocating budget to different kinds of resources, OR kind of thinking. Combat modeling, developing OR to kind of model how to behave in like a forward environment. That can be used to help with like force deployment, things like that. And like finding IEDs in Iraq, like that's a very OR kind of problem. It's literally like a traveling salesman problem, except like you're trying to find the bombs, not get killed. I mentioned that problem because that's work done by Chris Marks here in the ORC for his master's thesis. I believe his advisor then was Cindy Barnhart. So yeah, ORC is here like helping find IEDs in Iraq. So it's really important stuff. And at this point, like you kind of get that for these physical decisions you have to make in the national security, OR definitely plays a role. What's not known as much, not explored as much, is a different part of national security. And that's what's called the information environment, okay? So traditionally, what is the information environment? It's like things like, oh, we're in Syria, where are the enemy troops at? Where is their air bases at? Things like that. Where the enemies going to move to? How are they talking to each other? Spycraft, espionage, all this stuff is kind of tied to that whole information environment kind of aspect of things. And traditionally, it's not really a place where OR kind of had a role. Like when you think of like OR, you think of like Danzig or like other famous OR people. You don't think of like spy versus spy, right? But it turns out something happened in the past couple of years that changed the game. What changed was the information environment kind of expanded greatly. So it's not just like battlefield information and stuff like that. It's like the battlefield kind of embedded in a giant, huge social network of people. And people all over the world talking about the battle, okay? And maybe they're talking about like news stories, what's happening there, casualties, things like that. But in this particular battle in Syria, a bunch of people got together, started saying really weird things about the battle. So the group was ISIS, the Islamic State in Iraq and Syria. So this is like a group of Sunnis in the Middle East. They're trying to conquer territory in Syria and in Iraq. And what was novel about them was they were kind of the first to figure out we can actually leverage the modern information environment to like tactical and strategic advantage. So what do? They had this like flag they made, the ISIS flag, the black one you probably seen in the news. And they'd like take pictures of them rolling into like cities they're conquering. Then they'd post the pictures on their websites and have their social media users post a picture and they'd share it and it goes around and around. And the other kind of nasty things, like in the top corner, there's a tweet from one of the ISIS members. It's a British lady who kind of married a Syrian fighter and became like super hyped about ISIS. And she's like posting the address of the Navy SEAL like killed bin Laden, as in like go get him, right? Like a kill list or some things like that. So they're doing really nasty things with social media. And the purpose was, one purpose was recruitment. So people would see these like ISIS tweets, and I guess these like disaffected people all over the world, they get motivated, they join the gang, they like fly over to Turkey, and then from Turkey they walk over the border to Syria to join the fight with ISIS. So they're using social media to like recruit for their battle, because basically they're putting an image of like dominance, of power, of strength through like their memes and their flag and all the things like that. It's like an informational warfare game they're playing. And so it helped them like get soldiers to fight in the battlefront, but it did worse things than that. So here's a plot from the New York Times showing just a bunch of attacks all over the world, terror attacks that are either directly tied to ISIS or ISIS inspired. And some of the attacks happened right here on US soil, okay? And what's happening was people are kind of joining the whole ISIS movement online, they're sharing the memes, they're getting excited and radicalized, and then sometimes they go in the real world, and they do stuff, and they like kill people, and they commit acts of terror. And so ISIS was showing us that, yeah, suddenly this social media space is really important because it's like a threat to us, because people are using it to like reach disaffected people and make them do bad stuff they would normally do. So it kind of showed us, yeah, this space has to be like studied, understood, and dealt with, okay? So to deal with it, I mean, Twitter dealt with it because they didn't like the bad PR being like ISIS's favorite social network. They began to shut down all the ISIS accounts, just shut them down and kick them off the network, and that's how they fought them. Okay, there was no official like government response to this, and you think there should have been to combat these guys, but really it's the private sector trying to like step in and have some controls of these people. But they do things like you shut them down, they make a new account, they come back on Twitter, they go back at it. Like here's a back and forth battle, and there wasn't like a coherent strategy to like stop this kind of thing, okay? And it kind of showed that, yeah, there has to be some kind of strategy to like deal with this kind of issue of radicals using social media to like recruit and commit acts of terror all over the globe. So that was like one problem where we saw that for the first time, social media was like a national security thing, okay? Before that, for me, it was just tweeting and studying networks and a very like scientific curiosity. When ISIS kind of began becoming prominent around 2014-15, now it's like, okay, this is like a real operational problem. Let's find ways to deal with this thing. So first problem we saw was ISIS and Twitter, okay? The next problem we saw happened about a year after ISIS kind of died down, and that was the elections in 2016. So our intelligence community kind of assessed that the Russian government tried to meddle in that election through manipulating our social media here in America, okay? And what were they doing, allegedly? They were basically creating like fake social media accounts to kind of amplify and promote very partisan issues in America. For instance, like, remember the Kavanaugh Ford hearings? The Russian bots are there trying to like talk about that, retweeting stories about it, saying things about it, getting people riled up. The shooting in Florida in Parkland, the Russian bots are there trying to like gin up people's like agitation about gun rights and gun control. Laura Ingraham got in trouble there for like insulting one of the students that lived in that high school. Well, they were like out there, the Twitter bots, like defending Laura Ingraham for some reason. And you know, in 2018, they're trying to go at it again, trying to manipulate us. Although this time the government claims it's taking more steps to deal with it. I don't know how much that's true or not, but the point is like, the problem is ongoing. And the problem is this like influence campaign, that they're injecting stuff into our social networks to kind of mess with us, okay? And this is a much harder problem, in my opinion, to solve. And I think a much more dangerous problem. Not in the sense that casualties, but like this kind of campaign can shift a country's like geopolitics over time. They can create like seismic shifts if not dealt with. So Twitter's tried to deal with it. And they try to like shut down these Russian accounts and get them off their social media platforms, as did Facebook. But it's tricky because the accounts, like ISIS people look like ISIS. You know, I can see them, I can tell they're part of ISIS. In fact, they're proud to like broadcast the fact they put the flag up and everything. But these bots are trying to hide. They're essentially like spies, you know? And they look like us. Like some of their accounts are like actual American citizens. They just create a fake account for a real person and start posting stuff. Or they create like blogs, and the blogs look like regular American people blogging about whatever. That's some kind of like foreign account trying to like put up stuff to mess with us, okay? So it's much harder to like find these people and stop them from doing what they're doing, right? And what they're doing is they're trying to like get us all polarized and ginned up and like just believing crazy things and making us like hate each other. And it works because our society is vulnerable to it, because our society is polarized. So if you look at like the way people talk on Twitter, the network of interaction looks kind of like this. Like here's a network of people talking about a hashtag from a year ago called Release the Memo. What was this about? To be honest, I kind of forgot because there's so much news happening, but something about Russia and Trump and Devin Nunes and something about a memo being declassified. I don't know what it is, but the people talking about it just kind of like split into two camps. The Democrats thought this is like a way to undermine the Russian investigation, and the Republicans thought this is like corruption, the FBI trying to like undermine Trump. Just a polar discussion. So when your people are like that, then like bossing it in there and kind of like say things that normally you wouldn't believe, but because we're so tribal and separated, you might start to believe things like that. And you might question the legitimacy of elections, of the government, of authority figures. You just kind of create a whole mess in the social network. That kind of reflects in like the electorate. That can affect things like policy and the country standing in the long run and things like that. And these are like slow campaigns. It's like these things operate over like months or years, slowly, just to kind of like push us farther apart. And you have to find a way to deal with this thing, because this can be a threat also to like a democracy. Okay? So the DoD actually recognizes like this information environment is like something that has to be addressed and incorporated into broader military strategy. So as a report they put out back in 2016, so not too long ago, it's a strategy for operations in the information environment, okay? And like the one quote I kind of want to show you guys is this one here. Today's information environment poses new and complex challenges for military operations. Basically, this new thing out there, social networks, is important. We don't quite know how to incorporate it into like all we're doing, but we feel like it's something that has to be understood and incorporated into our decision process, okay? So information operations, like what is that? How do you kind of view what that is? The way I view it, it's like 4 kind of elements. There's monitoring, there's searching, assessing, and countering, okay? So what do these 4 blocks kind of represent kind of concretely? Well, one thing is monitoring, right? So monitoring means I want to like see what people are saying just to like make sure what's going on. Is there going to be a protest? Is there going to be a government being overthrown? Are people upset? What's going on there, right? But the first step to that is actually to figure out who I want to listen to collect the people that I want to monitor, maybe in a certain geolocation, like in a city or a town, maybe in some kind of online community or something like that, okay? Well, it turns out this question, and it's a question Chris Marks and I worked on during his PhD thesis, is actually an OR question. Because what we found was that you could actually solve that problem using some kind of like energy function you can define in the graph, and you minimize it by solving a min-cut problem. Well, a min-cut problem is an OR thing. So finding people to monitor in a social network is really an OR problem, right? I didn't know that before, but now, yeah, that's straight up OR, so that's cool. Thinking about this algorithm we developed here, Chris actually used this in the Army to monitor in Puerto Rico after Hurricane Maria what people are saying about the government response to it, just to like see if like our response was effective helping the people out there in Puerto Rico. So this is being used in the military today to like find people to monitor. Okay, so monitoring is one important problem. Another important problem is searching the social network, and you're searching it to find these malicious actors. Maybe you want to find the ISIS people so you can like shut them down so they don't like post addresses of soldiers. Maybe you want to find the bots in the network trying to mess with your head to get them out of there to like have a clean, fair election and not be manipulated, okay? Well, it turned out the search problems are also straight up OR problems. Like finding the ISIS people, well, we showed that, yeah, actually that problem can be solved using some kind of Polyas-Earn model. Polyas-Earn is like a probability model, and we all know that probability is a big part of OR. I mean, some people may question that viewpoint, but I still like probability in OR, and yeah, that's an OR problem, right? Finding terrorists. Finding the bots, well, it turns out we found that actually we can minimize some energy function with a min-cut on some graph to find bots. So again, an OR solution to like this important information problem. So we can search for people, terrorists, bots, whatever you want. Assessing. So this is kind of new work I'm doing right now, but you know, you hear a lot of talk about the Russian bots are out there, they're messing with us, they're screwing up a democracy. A question to ask is, how do you assess the impact they're having on the population? Are they really shifting opinions? If the bots hadn't been there, what would have happened, right? Like how much in danger is our population? Well, it turns out to like answer this kind of question, we can leverage what are called opinion dynamics or consensus models. And a lot of these models are actually developed at MIT by actually John Tsitsiklis. His thesis was about consensus networks. Is John here? No, I guess he didn't make it today. But yeah, like this is stuff developed in OR to like study. I think he was looking at like bots in a network talking to trying to agree upon what is the temperature of the room. We're looking at people in a network talking about opinions and trying to agree upon do I like Trump or Hillary. So we modify those models, applied them to this modern Twitter environment. And now we got a way to actually assess, are your bots actually like messing with your opinions in the population? Very useful tool to have in information operations. And finally, this is my favorite tool, right? Countermeasures. So if the bots are in there and they're messing with you, right? And you want to counter them and negate the effect they're having, right? Maybe I could put my own bots in the network and stop them from doing what they're doing or have the opposite effect of what they're doing. And it turns out that putting the bots into a network to shift the opinions to mitigate some influence campaign, also an OR problem. Because you got to decide where is your bot going to connect to in the network. So you, yes or no, binary variable. It turned out it's a big old integer program, or an IP as some people call it, right? That's an OR thing in integer programming. So we have like another OR solution to this important information problem. Where do you put your bots? And kind of being more creative, and this is, again, my viewpoint, not anybody else's. Once you can do this, you can go into forward areas and like, persuade people in other networks to feel a certain kind of way. I'm not saying you should do that. I'm just saying like that's what you could do if you build these kind of tools, right? So, just to kind of wrap up here, the information environment has changed dramatically and has become a lot more important for national security, okay? And as it's doing that, a whole bunch of problems popped up that before didn't seem like they're really important national security problems, like who to talk to in a social network or how to find people that live in like, France that like talk about stuff on Twitter. Those are like not really national security things, but it turns out today, yeah, those are very important national security problems. And the nice thing is that those problems are straight up operations research problems. If you look at them the right way, right? If you view the problem as a kind of operational challenge, then OR solutions will pop up to solve those problems. And so those are the kind of things I think OR in national security should focus on going forward is this information environment and information operations. So hopefully next couple of years, when you think of OR in the military setting, it won't just be tanks and bombs, right? It'll be tweets and bots. Thank you.
We have time for questions.
Yeah, really fascinating talk. I loved it. So I have a few questions. First off, how did you collect all this data? And is this still theoretical at this point? Because how do you implement it? I mean, other than the counterbot, you would actually have to reach out to Facebook and Twitter, the private entities, to shut down those accounts, right?
So the beauty is we do most of our action in Twitter because Twitter is like a public social network. So yeah, that's about getting data. I guess I can't go back in the slide, but yeah, if I want to collect like the algorithm for monitoring, right? You just give the algorithm like 5 people's names, are in the location, like a couple of keywords. Like if I want to get people in Boston, I just give a couple of people in Boston, like Dimitri's on Twitter, I'm on Twitter, so 2 names, a couple of keywords to look for, Red Sox, Boston, right? And it just runs on Twitter, uses their public API, and in a couple hours you have like 30,000, 40,000 people in Boston that you can monitor for stuff like that. Yeah, all public searches. But the beauty is they're all public. Even the ISIS people, like I couldn't believe this. The ISIS people on Twitter just put in pictures of like people getting their heads cut off publicly. Like they're not even hiding it. They're open accounts because they want to be seen. Like the social media's made people want to be like divas. They want to be seen. So you can use that to your advantage, like collect data about them and see what they're saying. And, oh, you're cutting his head off. Okay, well, let's find where you are and get you off Twitter because you're not really a nice person. So yeah, it's public data, a lot of it. Not all of it, but a big chunk to do what you want to do.
About the implementation part of my question.
Oh, that code for the monitoring thing, we put on GitHub, so you can just run it thing tomorrow. It's already ready to roll. The other stuff we did, yeah, it's like very easy to implement. Like the stuff I showed you, I applied to real data. So it wasn't just like a theory thing. It was like, here's what you do to like figure out where the bots are, right? Run this code. Here's what you do to like figure out how much the bots tip to your opinions. Here's what you do to like put the bots into this network and target people there. So it's implementable, I guess. Like just do it. Yeah, so that's the nice part about it. Like here's what's dangerous about it. Because it's like this new environment, non-state actors can get the same kind of power as like a government, right? So the bots could be Russian, Chinese, or Iranian, or it could be that 400-pound guy in the basement, right? They all have the same power to access this medium. So it's kind of scary and kind of maybe, I don't know, cool in a sense. Larry.
Have you incorporated behavioral aspects of how people, particularly in a polarized environment, interpret and process different kinds of messages?
So I'd say right now, this stuff we did so far is kind of like strategic, as in like, okay, here's the network, here are the targets, go get them, right? The answer to your question is a much more tactical one. So how do I actually create a bot that can say things in a social network and make people change how they feel about it, right? And it's just science. So you have to go in there and figure out the models, what works. So right now we're actually doing some experiments trying to like see how to actually tactically put the bot in there and what does he say to the targets to make them change how they feel. So I don't know yet, but hopefully I'll find out in a couple of months and then deploy them. I don't know. But yeah, it's an important, like psychology is an important part of this whole thing, right? You can't really do this without studying some psychology. Like it's not just networks and graphs and flows, it's like, it's people, right? So I think it's important to like do this stuff, take a couple of courses in psychology, just to understand like how people think and stuff like that. It's important.
So historically, before you had all of these networks, you had information operations, but they worked on a much slower time scale. You had, for example, airplanes flying over civilian populations in disputed areas and dropping leaflets, sometimes spreading mistruths, but which were to your advantage to try and get people to, turn against an enemy or at least not to fight back, something like that. Or, of course, you have radio broadcasts during all of the wars that you can think of, basically trying to, disincentivize the citizens, cause them to be oppressed, what have you. What seems to be going on here are two things. One, more than two things. The speed is much greater because stuff happens so fast. And one of these tweets comes out, and its entire lifespan is what, 5 minutes or something?
Maybe a day. But it can do its damage in a day.
But I mean, in terms of like how long does it take until it reaches 95% of the people it's ever going to reach or something? It happens very quickly. And so many more people are immediately accessible to it, and it becomes possible to do the targeting in a much finer grained way. So I'm just, the question, I guess, is in terms of the effectiveness of these things, is it really all that different from what you had before in terms of the radio propaganda, in terms of the leafleting, and it's just that it's happening so much faster? Or is it really that the connectivity aspect of it has actually, you're seeing qualitative results from these campaigns?
I think what's different now is that when I'm flying a plane over like a city and dropping a leaflet saying, stop fighting us, we're gonna win, just chill, right? It's like using a blunt instrument, right? Just dropping everything all over people. And then they pick up the flyer, they read it, and like whatever, right? Now it's like you don't have to drop a big flyer in the whole city. You can target certain people in the city. The flyers are just like tweets, so they're free to make. And people can share a tweet. You can't really share a flyer like the way you can share a tweet, so you can actually make them propagate. And so it's a much more finer kind of targeting, and when it's a finer kind of targeting, that's the kind of place where OR does its thing, right? Like, okay, now optimize who goes where, right? And so that's why these become OR kind of problems, like classic OR kind of problems all of a sudden, because you can just figure out where to put the flyer exactly in the network. And you
also the deception. When you have the airplane, people know where it's coming from. In the both cases,
yes,
it could come from someone that might look like the other message that you got that was completely.
Yeah, these are like spies, right? Spies among us.
I remember pretty clearly in Israel during the 1973 war, there were these demoralizing messages that were coming over Egyptian radio. How many soldiers were killed in the battle today? How come your government isn't telling you what the casualties were and stuff like that? So.
And I'm betting that was done in my sense is in a very qualitative, heuristic way, right? But now, like, because you can target things so precisely, all that stuff that was done with heuristics can now be done in a precise OR way. I mean, based upon the heuristic, you can develop cool models to say, here's how you should send the message, when you should send it, who should hear it, et cetera, et cetera. So it's like, it's OR all of a sudden.
Retzef, can I? So let me add one thing I think that may enlighten us a little bit at a more general level. The military has developed a lot of tools for what you kind of described, broad warfare, right? So this is what's going to happen in the Fulda Gap when the Russians and the US meet. The current environment has challenged us in this area as well as the topics I talked about because it's not what we had generally thought about as war. And so the OR techniques here specifically work in a different environment, I think, than we traditionally had, where we were, even in the Persian Gulf War I, where we were broadcasting things, we had leaflets. I think it's just the environment has changed so much when you look at the conflicts we're in today.
These are InfoWars we're in now.
Frankly, there may be different actors in this, different governments. We have different views on what's a threat, what isn't a threat, what isn't ISIS. How relevant is that to this? And then secondly, are you working with authorities in this? In which area are government authorities?
Define authority.
Can you repeat the first question?
What was the
first question?
The first question is
people in Europe might think of this very differently than people in the US. People in Asia might think of this very differently. How do you...
I mean, even the people in the US thought about it differently. So, true story, when I began this ISIS project with Chris, I think some faculty in Sloan like heard about me trying to build algorithms to shut down accounts on social media, and they were very mad about it. They thought it's like censoring free speech and it's like gonna use by authoritarians to like suppress, dissent. And then I got yelled at. But then I kept doing it. And then like ISIS kind of became huge in like 2014, 2015. And that same faculty member said to me afterwards, your paper is really amazing. It's really solving an important problem that we have to deal with, and these people are a threat. So people's perception change as the situation changes. I didn't have to do that yet. So yeah, I think you have to be careful with this. I mean, even with my research, so some of it's funded by the military. And they gave me strict rules. Don't you dare mess with any US social data. So the stuff I do with like any like American citizens is like a separate funding entirely, not tied to the military. Because if I do that, I'm violating what's called the Hatch Act, which is using federal money to manipulate like elections and stuff like that. Because like imagine, right, I do this analysis with funding from the government, and I find like, oh, these are the people that have this opinion about whatever, right? I guess like Trump could use that to help his election next time around, and it's federal tax money helping him electioneer. That's why that law exists, right? So we have a lot of constraints here. Russia and China don't have those constraints. They do whatever the hell they want. And that's why I feel like in this space, and Eric, maybe you know more, but I feel like we're behind the curve. Like in conventional forces, we have an advantage. There's no way like a Russian tank is gonna beat our tank, But like the Russian bots, I think right now will actually do better than our bots because they aren't constrained. They do whatever they want. And so I think like maybe this work before the election seems kind of like, ethically questionable. After the election, all of a sudden, like I've been given talks at like think tanks in DC, and they love it. They're like, yeah, this is great. We're gonna fight the Russians. They're like liberal think tanks, right? But the situation changed their perception of what we're doing. And that's just kind of part of the game, that until it happens, nobody thinks it's like a big problem, right? And the second question was authorities. No one really yet. I mean, so Chris was in the Army, and he's using some of the methods in the Army, the collection stuff, the monitoring stuff, and the ISIS stuff. The bot stuff is kind of very new stuff, so I guess authorities. Russia Today contacted me and asked me to be on their TV show to talk about that paper. I said no because I'm a patriot, but maybe slowly it'll get out there and... Exactly. So yeah, not yet, but hopefully like they will take notice because the issue is becoming more important. But we're realizing it. And that's a good thing.
I think it's partly has to do with the fact that I think that once you leave the military and you look on other organizations that are responsible for aspects of national security, if it's food security, cyber security, I think that the familiarity, and Lara, you probably have perspective, the familiarity with operations research methods is far reduced, and the number of people that even have scientific quantitative thinking and understanding of data is far reduced. So, working with these organizations is far more challenging than to come to the military where you have an infrastructure and a culture and many, many decades of thinking in terms, the mindset of operations research. It's just a very, very different challenge to convince other organizations that this stuff is useful or even understand what does it even mean. At least that's my experience. I don't know to what, in other contexts. So.
When things go bad, then suddenly these methods seem important. So I guess in a way, like ISIS and Trump helped me a little bit, the Russians. Like suddenly this work was like important work. And before it was like, oh, this is like joke stuff, Twitter stuff, who cares? Now they care. So, yeah, I was right.